Okay, this video covers section 5.7 variations. So before we go into the two types of variations, let's first define this variable k. So we're going to let k be a non-zero constant real number. This variable k is going to show up in both our types of variations we're going to talk about, and it has a special name. It is the constant of variation. So now that we have our k defined, let's define the first type of variation. This is known as direct variation. Now, direct variation can be described or written as y. Let's go ahead, direct variation in terms of x and y. Just go ahead and make that distinction. So this is going to be y varies directly with x, or it can also be written as y varies, or y, find the erase button here, y is directly proportional to x. So these both describe the same thing in terms of x and y. So we have y varies directly with x, or y is directly proportional to x. Now, a way these can be described algebraically is y is equal to your constant of variation k times x, right? Or if you wanted to have it in terms of k, right, you could divide both sides by x and you end up with y over x is equal to k. So I put this over here because we have y is directly proportional to x. So reviewing what section 5.6 talked about, right, a proportion is two ratios that are equal to each other. So there's your first ratio of y over x, and it's equal to some constant k, right? And it's a real number. It can be written as a fraction. So here is your kind of directly proportional, kind of reviewing section 5.6. So before we go on to the second type of variation, I just kind of want to point out something that I think everyone has worked with that will hopefully kind of describe this constant of variation k. So recall that, oh, hold on. This is an example. Okay, got that out of the way. Okay, so recall that the area of a circle. So the area of a circle is given by the area is equal to pi times the radius squared, right? So no matter what your radius is, right, your radius can change, and when it changes, you multiply it by pi and you get the area, right? Or if you're given the area, then you know that it's going to be pi, right, 3.1415 times whatever the radius of the circle is squared. So it looks very similar to this, where y and x may change, but you're always going to have this constant, right? In this case, it's pi. So here we have a direct variation. Here we have someone struggling to change the color of the pen, where pi is your constant of variation. So in reality, the area of a circle is directly, well, hold on, let's do the, write it out like this. So the area of a circle varies directly with the radius squared of that circle, right? So there's just an example of a direct variation, right? We have the area of a circle is, it varies directly with the radius squared of that circle, right? So that's just an example of a direct variation, hopefully giving some meaning to this constant variation, constant of variation, right? Okay, so let's go ahead and define the second variation, and this is inverse variation. Again, just in here, it's in terms, this is in terms of x and y. All right, so just like we did up above, you could be asked to write the algebraic expression given this description here. So in this case, it's going to be y varies inversely If you guys were in class, you could help me verify how to spell inversely. Hopefully you're yelling at your computer screens right now being like, that's how you spell it. How do you not know how to spell inversely? Oh, see, I had it correct in my notes. I just was doubting myself. Okay, so anyway, let's get back on track here. So y varies inversely. Man, I'm just spelling it wrong all the time now. Okay, so y varies inversely with x. Or you can also say y is inversely proportional to x. So let's change the color here. Let's watch me try to go through this. All right, there we go. Let's choose blue. Okay, so up here we have y varies directly with x, right? This multiplication between k and x. But if y varies inversely with x, right? Think about what the opposite or what the inverse of multiplication is, right? How do you undo multiplication? Everyone together? Right, division. So when it varies inversely, we have division from x, right? So here we have y is equal to k divided by x. Or, again, if y is inversely proportional to x, we can solve for k, right? We can solve for our constant of variation, and what we end up with is y times x, or y, yx or xy. Right, so there are your two types of variations. Let's scroll down here, move this up. Yeah, let's work a couple of examples here. So first things first, it wouldn't be a lecture for me if there wasn't an example that I don't want to use. I've got two number sixes. We're going to get rid of the first one. Okay, so let's look at number 5. So suppose that y varies directly with x. So there is your important information here. So y varying directly with x. If we go back up to the top here, we know that y, when it varies directly with x, we have this constant of variation times x. Or you can also have it set equal to k, right? Where you have k by itself, dividing x on both sides. So here is your answer to A, right? It just wants a direct variation equation relating x and y. So notice here, we need to find y when x is equal to 3, right? But we need to figure out what k is, because notice, if we were to plug this in here, I'm going to go ahead and say we're going to look at this one. Well, hold on. Let's do the other one here. Let's just to show you why we need to find k. If we looked at this one, right, they're the same thing. Y, if we want to find y when x is equal to 3, well, we have k times 3. But we don't know what k is, right? So there's no way to figure out what y is. So we need to first find k. So again, let's just use this equation since we already have it circled. So we want to use y is equal to k times x because it's our direct variation equation. And we're going to use when y is equal to 4, then we know that x is equal to 16. Right? That's just given from this up here. So we need to solve this for k. So plugging in our values, we've got 4 is equal to k times 16. Right? Plugging in everything. Divide both sides by 16. We have 4 over 16. But then, go ahead and simplify this down. This gives us 1/4. So now, if we go over here, we now have our missing information, which is k. So k is now 1/4 times 3 over 1, or just 3, and that is equal to 3/4. So y is equal to 3/4 with this direct variation between x and y. Okay, so in a similar manner, let's look at this down here. Don't pay any attention to number 7. We'll do that one here in a second. But again, the first part here is telling us what variation equation we're going to use. And we're going to be using it when y varies inversely with x. So again, you go back up above, we have that y is equal to k divided by x, or y times x is equal to k. Now, just like down here, you can't plug in x is equal to 4 without finding what k is, right? Without finding our constant of variation. So again, we need to find k. Now, we're going to use, let's say, for this example, let's use this one. Up above, we used the other one, but this equation here is set equal to k, right? So all we got to do is plug in what we have. Right, we know that y is equal to 3 and x is equal to 8. That'll tell us our k. So again, we're looking at y times x is equal to k. We're going to use y is equal to 3 when x is equal to 8. So plugging those values in, we have that 3 times 8 is equal to k, or k is equal to 24. And there is our k value here. So down here, if we want to find y when x is equal to 4, that means we're going to, again, we can use this one. So we've got y times x is equal to k. Well, let's plug in all the values we know. We know that x is equal to 4, so we've got y times 4, and then we know what k is now, right? K is 24. So y times 4 is 24. What number times 4 gives you 24? All in unison. Good, we get y is equal to 6. And there is your solution for that. Okay, finally, the last type of problem that you're going to be asked to do is write an equation that expresses these different types of variations, right? We kind of had practice with that up above. But here we have p varies jointly with d and u, so we haven't defined what that means. So down here, real quick, let's define what joint variation means. Just kind of look at an example. Okay, so again, k is going to be a non-zero constant real number. K will show up here as well. And if we were going to write out, again, the, grammatically, right, writing it out with words, we would have that y varies jointly. Now this time, let's use variables z and w, right? So we're saying y varies jointly with z and w, or, right, it can also be written as y varies, or y is jointly proportional to w, or to z and w. I don't know why I put z and w that way. W and z. I just swapped them around. Oops. Small thing, but with w and z. Okay, so there it is written out, describing it. But now if we actually wanted to write it out algebraically, use green this time. Again, instead of just 1, right? So let's say if y varies directly with w, then we would have y is equal to your constant of variation k times w, right? That would be with just y varying directly with w. But we have jointly with w and z. So this is going to be k is equal to w times z. And that right there is your equation that describes this situation right here. So let's go up here and look at this example. So we want to write an equation that expresses the following relationship. P varies jointly with d and u and inversely with v. So first off, we have P varies jointly with d and u. So similar to the problem down below, but then we've got an extra P varies inversely with v. So that yellow's going to look kind of weird, but we're going to go with it. So let's look just at this first one here. So we're going to use k as our constant of proportionality. This is another way of just saying variation, right? So k is representing the same thing we've been using it for. So here we've got p is going to be equal to k times, and so just like down below, right, jointly with d and u, we've got p is equal to k times d times u. But now we have an extra information here that p also varies inversely with v. So going back up above, that defined what inversely had, we end up with this right here. We have that p varies jointly with d and u and inversely with v gives us this expression, just using our definitions of variations. So that is another type of problem that you could see.